Yes, what will happen that after the rain, so many water droplets will be there in the sky. Okay. Now from few, the sun rays will go through those water droplets and get refracted, totally internally reflected and dispersed. Now a rainbow occurs at the opposite side of the sun. If sun is here, suppose the rays are coming, then from few raindrops, what will happen? The ray will enter and then after that it will disperse. Okay, disperse as well as it will refract. Then after dispersion, it will go on the other side of this interface. This is the it is the denser medium and it is the rarer medium. Total internal reflection takes place at the interface of denser and rarer medium when the ray is entering from denser into the rarer. Now, if the angle of incidence for these rays is greater than the critical angle, then what will happen? These rays will get reflect back. Instead of refracting in the other medium, it will reflect back, and then here again it will refract when it is coming out, and when it will enter into the observer's eye, it seems to the observer as if the sky is colored, or you can say that the colored stripes are there. Okay, rainbow occurs on the opposite side. So the raindrops, it happens because of the wavelength of the colors and because of the direction of the sun rays. It occurs through the few out of millions and millions of rain droplets. Only through the few droplets this phenomena will occur. Okay, so now after that, this can be seen in a particular angle. At a particular angle we can see that rainbow. Okay, that is why we cannot see the whole sky colored, only the part of the sky seems colored. Okay, now this is the case with the rainbow. Next topic on your in your book is atmospheric refraction. Okay, in this one, atmospheric refraction, on page 194, it has been given there that due to atmospheric refraction, first of all, what is atmospheric refraction? We all know that rays are coming, the sun rays are coming or light rays are coming from the vacuum into the earth, and then when it enters into the earth's surface, earth's atmosphere, then atmosphere is denser than the vacuum. We all know that it is denser, so it will refract. There it will refract because it is coming from vacuum into that medium. Light rays will refract, so it will change its path. Because this changing of path due to the atmospheric refraction, atmosphere is called atmospheric refraction. Okay, this phenomena can be explained in the terms of the twinkling of stars can also be explained by this phenomena. The apparent position of the star is higher than the actual position, that also can be explained by this phenomena. And the planets do not twinkle, and sunrise and sunset 2 minutes before and after, that can also be explained by this. Now I will go one by one. First of all, the stars are twinkling and apparent position of the star. We all know that stars are these are the sun, or you can say that huge source of light, but because it is very, very far away, that is why it seems to us as if it is very small. Okay, suppose this is the star, actual star is this. Now when the rays are coming, it is coming in the atmosphere. This is earth, suppose this is atmosphere. Okay, when the rays are coming in the vacuum, these rays will move straight. Okay, it is considered that these are coming straight. As soon as it will enter into the observer's into the atmosphere, first layer of atmosphere, it will refract a bit, then it will refract more, then it will refract more, and when it will enter into the eye of the observer, suppose this is the observer, then what will happen? The observer, because it is the property of our eyes that it seems, or the brain interprets that light rays which are coming straight, these are coming straight, though it has bended here, but the brain will make the image of this star here at this position. Okay, at this position, because for the brain the light rays are coming straight, so the brain will interpret, or brain will make our eyes see the image of, or you can say the apparent position of the star higher than the actual position of the star. This is the first phenomena, apparent position of the star. The question can be framed, apparent position of the star is higher than the actual position of the star. Now the next one, the twinkling of stars. Twinkling of stars can be explained also by this. What will happen? We all know that in the atmosphere, atmospheric refractive index, or you can say density of the atmosphere, changes as a because of the natural phenomena. Sometimes air is flowing, sometimes some heat will be generated, then the refractive index will change. So because of the change in refractive index, the position or the refraction of this will also change. So what will happen? It may appear sometimes the apparent position may be here, sometimes the apparent position may be here. Although if the apparent position of the star changes, keeps on changing, because of that the twinkling effect occurs in our eyes. Okay, because of that, because sometimes star seems as if it is here, sometimes seems as if it is here, sometimes here, sometimes again here. So this creates the blinking or twinkling effect in our eyes. Not blinking, you can say that twinkling effect in our eyes. So this is the case with the star, twinkling of stars. But the planets do not twinkle. On the next page it has been given the whole paragraph that why do planets not twinkle. This is the third question which can be framed for atmospheric refraction. Now the planets do not twinkle because planets are nearby source. These are not the luminous objects. These get the intensity, these get the light from the sun. Okay, the sun rays, but these are refracting the light. When the light rays are entering, suppose the light rays are entering, again it will refract and then it will enter into our eyes, eye of the observer. I am just showing because it is nearby. So what will happen? It seems bigger than the star. Though we all know that stars are bigger than the planets. Planets are very small. Our sun is also a star which is very big compared to that planet. So that means, but because these are nearer to our eyes or nearer to the earth, then what will happen? It seems bigger. So it seems the combination of the stars. You can say that if the rays are entering from this side sometimes and these rays are not entering into the observer's eyes, after some time the rays from here it will enter and these rays may not enter. So what will happen? At the whole, the total intensity of light which is entering into our eyes, it remains the same. It nullifies the twinkling effect. Okay, because sometimes from this part may the light come, from say this part may light come, kabhi is part se aa jayegi, kabhi is part se aa jayegi, but always the light will be there in our eyes. So that is why the planets do not seem to twinkle. You have seen that in the sky also, some planets like the Mars and Venus, you can see those bright stars. Okay, that is called bright stars, but these are not the stars, these are the planets which do not twinkle. Okay, next phenomena which has been given here, that is the sunrise and sunset. Now sunrise and sunset as given on page 195, that delayed sunset and earlier sunrise. What will happen in that case? Again this occurs because of the atmospheric refraction. The earth is here, now the earth is here and the observer is here. What will happen? This is the horizon. If the sun is below the horizon during the sunrise, the sun is below the horizon. This is the atmospheric layers, you can say. These are the atmospheric layers. This is earth. So sun is below the horizon. What will happen? The rays which are going, then when it will go straight, after going straight in the vacuum, I have told you that from the stars also the rays were coming straight. So from sun also the rays are coming straight. Now after entering into the earth's atmosphere, this refraction occurs. These rays are coming and then this refraction occurs, and because of the refraction, instead of going in that direction, it will bend and it will enter into the observer's eyes. Okay, you have to show the figure for this in the exam if it comes, then it will enter into the observer's eye. It has been given there in the book also. Now it again the same phenomena that eye or brain interprets the image of the object as if the light rays are coming straight. So what will happen? The observer will see as if the light rays are coming from this point. So it seems the observer can see the sun 2 minutes before the sunrise. It can see. The same phenomena occurs during the sunset. The sun has gone down, but the rays which are coming straight, these will bend and then, You can see the rays which are coming, these will bend and it will enter into the observer's eye. Then the observer will see as if the sun is here only. Okay, this is the apparent position of the sun. Okay, it can see the image of the sun above the horizon 2 minutes after the sunset also. After that, sun will go more down. Then after coming down, then in that case the rays will not be entering into the observer's eye. Okay, so this is the case. These four phenomena, if it comes, why does it occur? You have to reply in this form. First, the reason. For every phenomena, why? For why, you have to give the reason. So in these phenomena, you have to say that for the apparent position of the star, for the twinkling of star, for not twinkling of the planets, and for the sunrise and sunset 2 minutes before and after, for that you have to write there that it occurs because of the atmospheric refraction. Okay, so this is the case for atmospheric refraction. So we have done 5 phenomena, rainbow also, and these 4 phenomena. So this is based on the atmospheric refraction. Okay.